Ethical Hacking and Penetration Testing, brought to you by Edionics. This is Chapter 3, Scanning and Vulnerability Assessment. So in this chapter, hopefully you'll be able to cover vulnerability identification and assessment techniques. So a vulnerability assessment is the process of identifying, quantifying, and prioritizing, or ranking if you will, the vulnerabilities in a system. Examples are systems for which vulnerability assessments are usually performed are everything from your average day-to-day IT systems in an office and a network, right the way through to energy supply systems, transportation systems, any kind of safety critical system as well, water supply systems, that kind of thing, and as I've also said, your average information technology system as well. Assigning a quantifiable value, or at least a rank in order and importance to those resources, identifying the vulnerabilities or potential threats, is good for migrating the risk away from yourself, and you can eliminate the most serious vulnerabilities almost immediately. You can get them fixed, and then you can move on to some of the lesser ones. So it's a good idea cataloging assets and capabilities in a system. You assign a quantifiable value, or at least a rank order and importance to those resources. Identifying the vulnerabilities or potential threats to each resource, and mitigating or eliminating the most serious vulnerabilities for the most valuable resources. When we talk about valuable resources, we're not talking about how much the server costs. We're talking about how much the company would be charged if there was some downtime for that server or that service. For instance, it may cost £1,000 for a server, but if this web server is doing £1,000 an hour turnover, if that was to go down, you're potentially looking at a lot of money there. So to identify the vulnerabilities, or vulnerabilities versus threats anyway. Threats are defined as specific activities that will damage the system, its facilities, or its patrons. Threats include any actions which detract from overall security. They range from the extreme kind of terrorist-initiated bomb threats or hostage-taking to more common events such as pickpocketing, vandalism, stealing of data, that kind of thing. Those responsible for identifying and assessing threats and vulnerabilities must not only measure the degree of potential danger, but the chances of that particular danger actually occurring in the first place. So that's a threat. A vulnerability is defined as the susceptibility of the system to a particular type of security hazard. Vulnerabilities can be corrected, but risk analysis must be undertaken to determine which vulnerabilities take the highest priority. Because transit systems cover a vast amount of territory that's often unfenced or otherwise unprotected, all equipment is vulnerable to some kind of attack or graffiti, for instance. It's the same for any kind of web server that will be sitting in a DMZ. So some of the things you can use to identify a vulnerability is a port scanner like Nmap, a vulnerability network scanner, as we've already said. You can use Nessus, Saint, or OpenVAS. Web app security scanners like Nikito and W3F. Database security scanners, Scuba database scanner. A host-based scanner like Linus or Uvalde. ERP security scanners and single vulnerability tests as well, which would be, say if Microsoft realized that their new version of Notepad was vulnerable, and to identify it you had to download a little tool and it would only check for that one vulnerability. The best one I can think of a few years ago was a Blasterworm virus, which took down most Windows systems. It didn't do much physical harm, but it would basically just give you a countdown timer to say your PC is going to shut down in 3 minutes. That was it. And Microsoft released a little scanner and a little patch which got rid of that particular worm for you. So a vulnerability scanner allows for early detection and handling of known security problems by employing ongoing security assessments using vulnerability scanners, it's easy to identify security vulnerabilities that may be present in the network from both the internal and the external perspective. So a new device or a new system may be connected to the network without authorization. A vulnerability scanner can help identify rogue machines which might endanger overall systems as well as network security. And a vulnerability scanner helps to verify the inventory of all devices on the network. The inventory includes device types, operating system versions, as well as patch levels as well. It might even cover user accounts, hardware configurations, and any other relevant system information you can think of. It's usually useful in security management and tracking. It's also very useful for a hacker if they were to get a hold of this inventory. It would save them doing any kind of footprinting on the system at all, because you've already done it for them, you just didn't store it in a very secure location. So now, problems versus solutions. Scanners aren't without their limitations, not by a long shot. The drawbacks of vulnerability scanners are that they only take a snapshot. A vulnerability scanner can only assess a particular snapshot in time in terms of a system's network security status. Therefore, scanning needs to be conducted regularly, every day, every week, every month, as well as some kind of IDS or IPS as well on the system would be great. New vulnerabilities can emerge anytime, and you need to know if your vulnerability scanner has just got a definitions update. You need to make sure it's going to be run against your system, or even if there's any software updates on the software you use within your system. That could easily introduce a new security hole, for instance. Human judgment is always needed. Vulnerability scanners can only report vulnerabilities according to the plugins installed in the scanner's backend database. They can't determine whether the response is false or negative, or in the more common term is a false negative or a false positive. Human judgment is always needed after every scan. A vulnerability scanner is designed to discover known vulnerabilities only. It can't identify other security threats, such as those related to physical, operational, or procedural issues. For instance, a vulnerability scanner wouldn't protect against social engineering. It wouldn't protect against the receptionist who lets somebody in even though they don't have an ID badge, that kind of thing. So here we have how you quantify this information based on the common vulnerability scoring system. Its risk is equal to threat likelihood times asset value times vulnerability exposure. So that is risk equals how likely is it that it's going to happen times $10,000 an hour times the period of time that it'll actually be down for, say 24 hours. So the Common Vulnerability Scoring System, abbreviated as CVSS, is a free and open industry standard for assessing the severity of a computer system's vulnerabilities. It's under custodianship of NIST, NIST. It attempts to establish a measure of how much concern a vulnerability warrants compared to other vulnerabilities, so efforts can be prioritized. The score is based on a series of measurements called metrics based on expert assessments. The scores range from 0 to 10. Vulnerabilities with a base score in the range of kind of 7 to 10 are high, 4 to 6.9 is medium, and 0 to 3.9 is classed as low. You'll also find that some vulnerability scanners will give you information as well that it finds. For instance, a banner that tells you what particular web service being used wouldn't be a threat, but it's handy to know in case you want to get rid of it. You'll often find that in the results of any kind of vulnerability scanner anyway. So prioritizing. This is definitely an automated task. However, it's always good to see for yourself if something is going to be worthy of an immediate fix. For instance, a common one is the SNMP community strings on a server have left have been left the standard public/private, you might think, wow, that's a big hole, that needs to be changed immediately. But if port used for SNMP isn't allowed through the firewall, I think it's 121 or 161? 161, I think. If that's not allowed through the firewall, then is there really that much of a need to get it fixed straight away? An old version of Apache running on an internal web server, is that necessary to be fixed? Well, yes, potentially, because the attacks could come from the inside as well as the outside. And old user accounts still being active. It kind of depends on your infrastructure, really. If somebody's left, it's always best practice to remove the account immediately. However, if that account can only be accessed from a particular terminal in the building, then yeah, it may go unused for a while.